Welcome. This is Mrs. Nearing. In this video, we are going to talk through some of the symbols that we encounter in chemistry, and this is related to that first lesson in Unit 2. And what we observed is we observed various substances with different symbols. And what we should have noticed is that the ones with the G by them were gases, the ones with the S were solid, and then we had two groups of things that looked really similar. The ones labeled AQ and the ones labeled L both appeared to be clear liquids. But we can tell there's other, differing things about their formulas and their different symbols. They must not mean the exact same thing. And it turns out that L means liquid and AQ means aqueous or aqueous, however you want to say it, works just fine. And so what is aqueous? It's different from liquid. There's a different symbol, but it looks really similar. And what aqueous is, it means it's dissolved in water. So here's a side-by-side comparison of liquid sugar versus a sugar solution. And imagine this would be, like, let's say this is glucose. So C6H12O6 with an L by it versus C6H12O6 with an AQ. So molten liquid sugar would be we heated the solid sugar up to its melting point and now it's in a liquid form, versus aqueous sugar would be we took some sugar and we added it to some water and we made what we call a solution. So this is actually a mixture when you have an aqueous substance. It's a mixture of something in water. Here is another side-by-side comparison of what these various symbols mean. So table salt is something you're probably familiar with. Regular old table salt has the chemical formula NaCl. It's sodium chloride, and it's in a solid form at room temperature. So this would be solid NaCl. You can take some salt and add it to some water and mix it together, and then we would call it aqueous sodium chloride. So NaClAQ. Notice that the H2O does not show up in the formula. So where you see this AQ right here, this means dissolved in water. So that's what that means right there. So when you have something that's aqueous, it's actually a mixture of something in water. So it's a mixture of two things. And we'll get into what's happening at a particle level with this later on. We'll discuss solutions later on in the year. You could also have liquid sodium chloride. This would be pure salt that has been melted. And salt has a very high melting point, so you have to heat it up very high in order to get molten sodium chloride. Not something you can do at home. Each element has a name and symbol associated with it. It could be one or two letters. And here's some examples. Zinc is Zn. So that one might make sense. Okay, zinc being Zn. Some of them might seem weird, like sodium is Na and silver is Ag. It has to do with their root word. So silver comes from the word argentum, and the Latin word for sodium was natrium. So that's why some of these symbols might not seem to match the name that we're familiar with. And there are some elements that you should know. In here I put a highlighted list. And we've got a periodic table in our course resources that has all the names of these by them. So these are the ones that we will encounter commonly. So if you were interested in memorizing some common elements, these would be ones that you could look up the name of. This is not something that we're going to, test on in a virtual setting, but these are the common elements we will encounter. If you are interested in learning their names, you can make some flashcards or something at home. You might also be wondering about some of those other names we saw, like hydroxide and sulfate. Those are some examples we saw on page 1A. These are what we call polyatomic ions. And that is a group of elements that commonly stick together that we give them their own unique names. So, for example, hydroxide is what we call it when we have an oxygen and hydrogen combined together and forming an ion. Nitrate is 3 oxygens and 1 nitrogen. Those are the two main ones we ran into. We also saw sulfate, which is over here. Sulfate is 1 sulfur and 4 oxygens. And we will talk more about ions when we get into bonding, but I wanted to address that because we saw those names as well. And some more vocabulary. A compound is what we call it when you have 2 or more elements stuck together. The chemical formula is the set of symbols to represent the compound. So for example, carbon dioxide is a compound. It's a combination of carbon and oxygen. The chemical formula for carbon dioxide is CO2. It's important that we pay attention to which letters are capitalized. So when you are reading something and when you are writing out a formula, you have to be really careful about your capitalization. And here is an example here. If you write capital C, capital O, that means that you've got carbon and oxygen. But if you write capital C, lowercase o, that is actually the symbol for a different element known as cobalt. So these are two very different things. So you have to be really careful about your capitalization. On a related note, we can look at the number of capital letters to determine how many elements are in a substance. So if you only see one capital letter, like for example, Ne, that's just a pure element. So this is neon. If you see more than one capital letter, that means you've got a compound containing more than one element. So in this example, NO2, it has two elements in it. N is nitrogen and O is oxygen. So each capital letter is the start of a new element. And the other thing the other piece of information that a formula gives us, it tells us how many of each type of atom are in the compound. So these subscripts over here, like right here, Ag2, so Ag is the symbol for silver, and then this 2 means you have 2 atoms of silver. Over here you've got a 3 by the O, that means you have 3 atoms of oxygen. And then if you see no number there, that means you just have one of them. So there's 1 atom of nitrogen. So if we're looking at this formula, some things that we can tell from this formula. One is we can tell there are 3 elements in it, because we know there are 3 capital letters. We know there are 2 atoms of silver. There's 1 atom of nitrogen. There are 3 atoms of oxygen. So if we add those up, this compound is made of 6 atoms total. So these are some various things we can find from looking at this chemical formula. All right, so that was our video going over chemical symbols. If you have questions, reach out and let me know.